Hey everyone, so the purpose of this video is to cover how to use relational instruction sets within Proficy Machine Edition version 9.5, and we're going to be programming on an Emerson RX or PACSystem controller, notably the IC695 CPE 305. And once again, we're going to be exploring a number of different relational instruction sets. We may not be covering every single type of variable, such as integers or uints, dints, reals, long reals, words, dwords, etc., etc. But in essence, every instruction for that applicable data type is essentially the same. It's just working with a different data type. So I might just cover a few reals and integers and words just to kind of give you a feel of a good understanding of these instructions. So without further ado, let's get started. So I have here Proficy Machine Edition 9.5 open, and I have a very simple program here running on my controller. We can see under my hardware configuration, I just have a simple 7-slot rack with a power supply, of course my CPU, this is the CP305, and then in slot 4, a network module. In terms of our logic program blocks, I just have the very simple default main routine, which is blank. So essentially an empty canvas for us to start developing on. So let's start off with not equal to instruction sets. Now if I go ahead and I just make a simple change to this first rung, I'm going to put the NE, and you can see here, as I mentioned, we have a not equal to instruction set for all sorts of data types. Let's just deal with an integer, just for something very simple. We're making an online change, so we're going to edit test edit mode, and we're going to go ahead and just pass power here to the instruction, and we're going to talk now a little bit about the inputs and outputs. Now on the input side, it's essentially just comparing between two single precision integers, in1 and in2. If in1 is not equal to in2, or if in2 is not equal to in1, whichever it is, then power flow is passed to the output. So if I go ahead and just put a coil here, and I'm going to call this integers underscore not equal, and let's call this my integer underscore 1, and I'm going to copy this on the in2 input and just call this my integer 2. And we're going to save this. And once we've applied this program change, I'm going to start playing around with the values of those variables. So you can see here, the instruction set, NEInt, is being executed, and you can see here, well, these two are obviously the same value, therefore the output is not executed. But suppose I made this 1, and they're not equal, then we can see the output is executed. If I made it back to 0, we can see the output is not executed. So it's a very, very simple but powerful instruction that you can use in advanced or simple logic for that reason. Let's go on to equal to. It's essentially the inverse, right? We're looking to see if two variables are equal to each other. Now in this case, I'm using the equal to integer instruction, so eq underscore int, and in this case, power is passed because, hey, both of our integer inputs are the same. They're equal to each other. And now if I make this say 1, we can see they're no longer equal, therefore power is not passed. I'll move it back to 0. Now we're passing power because they're equal, and let's make the second integer input greater than the first, and yeah, we're not equal anymore. So very, very, very simple, but again, very powerful instructions. Let's go with a less than instruction set. So how about an LT? This is less than. This is not less than or equal to. This is just less than. So if I do a LT underscore integer instruction, it's comparing to see if the in1 variable is less than in2. And again, it's comparing two single precision integers. So in this case, is 0 less than 0? No, it's not. But if I make this say -1, well, -1 is less than 0, so it's going to execute. And now, suppose I make this 2. Well, is -1 less than 2? Yes, it is. Well, if I make this -3? Nope, -1 is not less than -3. So it's a very, very easy to use instruction. Again, very powerful. Now if we use less than or equal to, so the LE underscore integer, this is comparing if in1 is less than or equal to in2. And if they're equal to, great, power's passed. If they're less than, great, power's passed. So let's just make this 0 and make our integer 2 0. And can we see, okay, yeah, they're both equal, so great. Now what if this is -3? -3 is less than 0, so you're still less than the second one, therefore power is passed. What if I make this 5? Well, is 5 less than 0? No, it isn't. therefore power is not passed. And we also have the same set of instructions on the greater than conditions. So you can use a GT integer instruction if you so desire, that which just checks to see if in1 is greater than in2, not greater than equal to, just greater than. And in this case, 5 is greater than 0, so pass power. What if they're the same? Nope, don't pass power. What if it's less than? Don't pass power. And then on the greater than or equal to condition, we're going to use the GE integer instruction. And we can see here, if we are greater than or equal to, we'll pass power. So is -1 greater than or equal to 0? No, it's not. How about the same? Yep, they're the same. How about is 1 greater than 0? Yes, it is. Therefore, continue to pass power. So just some very simple but powerful instruction sets. Now let's jump to something a little bit more advanced. We're going to use comparison instructions. So what I'm going to do is I'm going to delete some of our logic here, and we're going to put in a new instruction called this compare, so CMP underscore. Let's continue to work with integers. And we can see here it's a little bit different. So let's first of all, let's just pass power to our input. And, if we pass power to the instruction, not the input I meant, just pass power to the instruction. And like we've always dealt with, we have an in1 and in2. Let's call this my integer 1 and my integer 2. And the unique side of this instruction set is you can have a variety of different types of outputs depending on how these two inputs relate to each other. So if in1 is less than in2, then we would have a less than condition. Or if they're the same, we can say they're equal to each other. Or if in1 is greater than in2, then it's greater than. So depending on, again, how they relate to each other, it's a very powerful use instruction, so you don't have to use, say, multiple less than or equal to or greater than equal to instructions based one at a time in different rungs. You can just use a simple comparison instruction. So 1 is greater than 0, therefore it's a greater than condition. So if in1 is greater than in2, then the greater than output is executed. Now what if they're equal to? Well, they're equal to each other. Great. So in1 is equal to in2, therefore execute the equal to's output. What if in1 is less than in2? Well, then we can see the less than has been executed. So it's a really powerful and useful, I would say, instruction as compared to, say, maybe using multiple less than or equal to or greater than instruction sets. And of course, you could even do something fancy and be like, well, I want to do it so that I want to execute on if it's less than or equal to, or maybe I want to do it so if it's less than or equal to 1 or greater than 1, or something like that. So what you could even do is something like this. I could even erase this equal to side and say something like this. So now what's happening is if in1 is less than or equal to in2, energize this one. So if I make this a 0, well, they're equal to each other, therefore then you would execute the, this actually should make more sense, so less than or equal to. Apply that. Okay, so if in1 is less than or equal to in2, then you would energize that output. So is 0 less than or equal to 5? Yes, it is. How about is it 5 equal to 5? Yes, it is. Now is 6 greater than 5? Yes, it is. So therefore, maybe you'd want to adjust your output so that only on the greater than condition, you'd want the another type of output execute. So you have a lot of flexibility here. Now the next thing I want to talk about is the range instruction. So we're just going to go back, create a blank canvas, and create our range underscore integer. And in this case, I'm going to pass power to our instruction so the instruction can execute. Now we're dealing with ranges as opposed to comparing two variables. So our in, we have a couple of inputs, L1, L2, and in. L1 is basically a limit. It's a limit 1, and then L2 could be our second limit. Now we have flexibility as to if we want L1 to be our upper limit or L2 to be our upper limit, and then lower limit as well. But to make things very easy, maybe what I'm going to do, I'm going to just call this 0, and then maybe make this 5. So L1 will be my lower limit, L2 will be my upper limit, and this will be my test integer that I'm testing to see if it's between the limits. And of course, I have my output. We'll call this, I'll just call it output 1. So let's go ahead and accept these changes. Okay, so basically how this instruction works is the range integer instruction tests to see if your single precision integer is within the range determined by L1 and L2. If it's within range, then you energize your output Q. If it's out of range, then Q is not energized. So in this case, we are within range because we're within 0 to 5. If I make this a 6, we're out of range. If I make this a -1, we're also out of range, on the lower end in this case. So it's basically depending on if you're in range. If I make it a 0, or a 2, or a 4, or a 5, we're within range. So again, a very simple but easy to use instruction, but it's also very powerful as well. And that's basically it when it comes to relational instruction sets. You can absolutely use the same types of instructions, but for real values. So if I were to say, change this to say range, oh, I'm sorry, there's nothing for the real, for the range variable, but there is for the less than or equal to, or greater than equal to, or not equal to instruction sets. So let's just say I call this real, let's do less than real as a quick example. Just something so we're dealing with real values and not integers, just to give you a little bit a better understanding of how to use those kind of data types. So let's say less than, let's call this my real 1. And we'll do this as my real 2. And we'll call this 2. And we'll just use a quick coil here on the output side. Call this my coil 4. Okay, so let's go ahead and just apply these edits. Now we're looking to see if my real 1 is less than my real 2. Well, 0 is not less than 0, so we're not going to be energizing our instruction. But if I make this say -5, then yep, -5 is less than 0. What if I make this -5? Nope, -5 is not less than -5. What if I make this -5.1111, something like that, and I make this -5.1112? Well, it is just a little bit less than my real 2 or in2, therefore the output is energized. So a little bit more flexibility, but also again it depends on how you're programming your PLC as well as the data types that you're using in your logic, but you do have the flexibility here. So thanks again for watching. I really hope this video was informative and you've learned something, and stay tuned.